Let us have another example of one population z-test. So let's have this problem. You recently received a job with a company that manufactures an automobile anti-theft device. To conduct an advertising campaign for the product, you need to make a claim about the number of automobile thefts per year. Since the population of various cities in the United States varies, you decide to use rates per 10,000 people. The rates are based on the number of people living in the cities. Your boss said that last year the theft rate per 10,000 people was 44 vehicles. You want to see if it has changed. The following rates per 10,000 people for 36 randomly selected locations in the United States are as follows. Here. So, pause the video and try to see if you'll be able to do the steps for hypothesis testing to solve this problem. So, before we continue, or before we solve rather, you might be thinking, sir, where did you get these numbers? These numbers are actually given. So, actually, these numbers should be given in the problem because those are the data that you usually collect when you do your survey and all that. But for the purposes of our class, these data would be given. So here we have this one. So first, we have to determine whether this is actually a one population z-test. And remember, to determine if it's a one population z-test, it should either be the sample size is greater than 30, or if it's less than 30, it should be normally distributed. Normally distributed. So let us check. The following are rates per 10,000 people for 36 randomly selected locations. So we have 36 as our sample size. So let's put it here. We have 36 as our sample size, which is greater than 30. So therefore, we follow the first condition, hence we can use one population z-test. So now let us do the different steps for hypothesis testing in one population z-test. Step 1 is to have our null and our alternative hypothesis. So let's first look for the claim. So based on the problem, we are looking for theft rate because that's what we want, or number of automobile thefts or theft rate per year because that's what you want to make a claim about. And your boss said that last year the theft rate per 10,000 people was 44 vehicles. So the claim is that the the average number of uh, automobile thefts would be 44 vehicles. And as you can see, since it's equal, because was, so that's equivalent to is, which means equal. So this is the claim, equality. Therefore, the claim this time would be in the null hypothesis. So our claim is that the mean is equal to 44. Now, what is now our alternative? As you can see, it only says if it has changed. It does not say more than, it doesn't say less than, only if it changed. Therefore, there's no greater than or less than, so our alternative shall be the mean is just not equal to 44. And hence, this is now a two-tailed test. So this will be our guide later on when we do our Excel. And speaking of that, we shall now go to step 2, which is doing the Excel computation. So now we shall go to data ribbon, data analysis, and our z-test here, and we click OK. So this time we shall change our variable 1 is this one here down below. Please forgive the annotations are staying because of the program I'm using. So there. And then our variable 2 is our dummy variable, which I have already included here. The mean difference is here, 44. And now, oh, there's no stated standard deviation. I'm sorry about that. Let me check first. The standard deviation given is 5.5. So, we will use that. So, the variance here, shall change this now, should be the square of 5.5. And the square of 5.5 is actually 30.25. I shall keep this, the one I used in the last computation, because this is insignificant and it will not really affect our computation. So, we have our labels, I'll check that, and our alpha. Oh, it's not given also. Wait, let me check. Now, we have alpha as not given because if it's not given, usually in statistics, if it's not given, our alpha is default 0.05. So therefore, we shall use this. So we shall now change this to 0.05 and we shall select our output range here near our annotation for step 2. If everything is okay, we click OK. So there we go. Let us just adjust so we can see the labels. And there we go. Now we should change this to steps 2 and 3. So now we shall now go to step 4. Since this is two-tailed, we shall refer to this p-value, which as you can see is actually 0. Now, if the p-value is 0, this doesn't usually mean that it is really equal to 0. Rather, this value is approximately 0 or very, very, very close to 0. So if that is the case, what we usually write is p and then a squiggly equal sign because that means approximately equal to 0. And that is obviously less than 0.05. So therefore, we should reject our HO. Thus, we shall conclude that there is sufficient evidence to reject our HO. To reject HO. Therefore, the number of automobile thefts per year change because it's not anymore equal to 44 as the null hypothesis is rejected. So we shall now conclude this one.